Hello everyone and welcome to image processing operations using Python programming. So if anyone hasn't seen our tutorials regarding basic Python programming, they can use our tutorials to go through them so that the coming sessions will be much easier to understand. So in this particular tutorial we'll be looking at how we can detect a particular color and separate it from the rest of the colors. So we will take an image and just do some operations on it. Okay, I'll just choose a program, image processing. Okay, color detection.py. Okay, this is what the program is about, color detection. So in this program, so we will be importing some packages. Import CV2, import Numpy as Numpy. So these two packages we have to import it before we start and begin programming. So all these packages need to be installed before the starting and upgrade the Raspberry Pi system. So I have used here Raspberry Pi. So the set of statements and packages to be imported and installed I have already documented. You just go through them and do a 6-line step. So you will be importing some Python, upgrading the Python version, and importing OpenCV package, which is a computer vision package used to work on images, for used for object detection, useful for face detection. All this purpose we need OpenCV. So that OpenCV is denoted as CV2 in Python packages. So that's what we have imported here. So otherwise it will return an error. So we have to import those packages. I am using here OpenCV4. So even you can use OpenCV3 also. So the first statement here is import CV2. It will import all the libraries from the CV2. And the next is import NumPy as Numpy, as NP. NumPy is a numerical Python used for mathematical operations, mathematical calculations, and functions. Those functions are stored in NumPy. So whenever we refer some mathematical operation, we'll use those functions from NumPy. And whenever in the whole throughout the program, when we say NP, it is referred to as NumPy. So okay, the first statement here is we are declaring an image variable. So image is equal to cv2.imread, the input image file what we want to work upon. So imread is a function defined in CV2 used to read an image and store it in variable image. So let's see what image7.jpg is. Our original image. So this is an image of gems lying dispersed on the floor, so that we get ample of colors and we'll differentiate. We can differentiate any colors from it. So presently I am using purple color to distinguish from the rest of the colors. You can use any colors, so but you have to choose some values. So we will go there, but first we have to convert the RGB mod color space to the HSV, hue, saturation, and value. So this color space. So in any image we have got multiple color space models. So first is RGB, the colored image what we see normally, and the next is hue, saturation, value, HSV color space, and finally we have a grays image. So gray is the black and white image. So these are 3 color models. So right now we are going to work upon .np array and .inRange function. So .inRange functions requires the input image to be converted to HSV model, hue, saturation, value. So HSV model we will be using for conversion, color space conversion. We will be using .cvt color. So this is present in again in CV2 library package, and it has input arguments as image variable, our input image file, and the next is cv2.color_bgr to HSV. So this is a code defined in CV2 package. So So this particular code, whenever we call this particular code, then it means that we want to convert from RGB to HSV. So here it is written BGR to HSV. In Python they treat in reverse manner, reverse way. So instead of RGB, red green blue, they call it blue green red. Both mean the same thing, but they write in this way. So not to confuse, it is conversion from RGB to HSV. So the resultant image is stored in HSV variable. So now here we are defining the limits of a color range. So any color has a range. Red has a range of colors. So it is not fixed to bound to one color, but it has mix and shades of colors. So it has some ranges. Those ranges depend on the values RGB or HSV. So we have to define that range and limit it so that our program should differentiate that color within that range. Suppose when we are choosing a color purple, then it should detect all the shades of color purple within this range. So lower limit is, we are calling this variable as weaker, is equal to np.array. So we are choosing HSV values. I'll tell you how we choose this. And the upper limit is stronger. We have variable we have used as a stronger variable is equal to np.array 150 to 55 to 55. This is also HSV. This is the maximum limit. So I'll show you how we choose RGB and HSV values. Go to desktop preferences and text color. So here we have got hue saturation value red green blue. So these values are belong to this color. Okay, this is what the color is. Now it has changed. So whatever color we want, this we can change it, the shade, and this is the color difference. So it is changing value. So we can choose this value, put a range, and we can work upon. I'm just cancelling so that our default values are restored. Okay, so here we will define limits, threshold limit. Now we have got CV2 dot InRange function, which uses HSV as an input image and weaker and stronger as threshold limits as arguments, and then it converts to a particular image which has only color belonging to this range, and that is stored in variable mask. So right here we are going to show two images after this set of operations. CV2.ImShow. ImShow is a built-in function defined in CV2 to display an image. So it has two arguments. The title name, first is the title name, which you can give anything. I'm writing here as original image, and the next is image variable, the original image we want to operate upon. And then the converted image we will be putting here using CV2.ImShow function, and we'll call it a result, and the image variable where it is stored and we have stored it in mask. And then wait key, we are waiting for the user to exit by printing enter key, and then after that as soon as the enter key is pressed, then CV2.destroy all windows is executed, so that all windows gets collapsed and the program can be executed. Okay, so alright, we'll go to build and execute and see the result. It will take a moment, but it will show the result. Okay, so this is what the original image we have seen earlier. Now we tried to separate purple colors. So this is purple color, this is also purple, this is also purple, and these four are also purples, and this is one is purple between all these different colors. So we can see these purple colors have been differentiated from the rest of the colors. Okay, alright, so this is maybe equal to pink, so it is not detected, I hope. So you can see a particular color is changed. I mean, it has been distinguished and separated from the rest of the colors using our InRange function. So you can change these values to get the different color range, so that we can separate different colors. So with this we are able to detect a color in any image. We can give any image here and check its input colors and give a particular color to be separated. After that we will be able to separate that color with the rest of the colors. So I hope it is understood. We have used all building functions using two libraries, CV2 from OpenCV and Numpy numerical Python. So I hope this is much better and understood easily. So see you next session. Thank you.